how to calculate depreciation. So here are the three methods that commonly used. So before 1981, the two commonly used methods are straight line. We also write it as SL, and that's one method. And another method used before 1981 is declining balance method. We also use dB to represent this method. And the straight line method will include the salvage value, and the declining balance method won't include the salvage value. Okay, that's just the difference between these two. And also they have difference in the formula, and we will talk about it later. And after 1986, so there is a method which is a standardized method used by the government. It's called MACRS, which uses the General Depreciation System, GDS. Okay, that's a table. And in this method, the salvage value is not considered as well. And also this method will be using two tables. It's pretty much like a table method. Okay, so let's just continue to learn these three methods. So the first one is called straight line method. It's a SD depreciation method. And so in this method, the book value BVK decreases linearly with time. Okay, so linearly means for a specific interval time, like 1 year, the decrease of the book value is all the same. So the first 1 year it decreases maybe 10,000. The second 1 year it decreases another 10,000, and so on. So for every 1 year interval, the decrease of the book value will be the same. That's what this linearly means. Okay, so it's if you draw it on the Cartesian coordinate system, it's gonna be a straight line like this. So this line means it's a linear relationship between the time and the book value. Okay, and it assumes that a constant amount is depreciated each year over the depreciable life of the asset. Okay, so if your depreciable life is 10 years, then during the 10 years, every year, it's the decrease of the value is gonna be a constant, will be the same. Then how do you determine what is the depreciation for each year, the DK? Okay, so before that, let's just talk about these variables, okay, in the formulas. So N is the depreciable life or the recovery period of the asset in years. Okay, so that's how many years you can depreciate. And B is the cost basis, including allowable adjustments. Okay, and this is the initial price plus the sale tax plus the fee to make everything serviceable. Remember that? And then DK is annual depreciation deduction in year K. Okay, so this is usually what you want to look at. And the BVK is book value at the end of year K. Okay, and SVN is the estimated salvage value at the end of year N. So after the depreciable life, the estimated value of that asset is SVN. And the DK star is the cumulative depreciation through year K. Okay, so these are all the variables, and we have already learned these concepts in the part 1 video. And then let's look at these formulas. So DK, that is the annual depreciation value in year K, okay? And that is B, the basis, minus SVN, the final salvage value, divided by N. So it means that you want to reach the salvage value from the initial cost within n years, and so how much you want to decrease every year. Okay, that's what this formula tells you. And also you can tell in this formula there's nothing about k, which means it's a constant, which means the d1 equals to d2 equals to dk equals to b minus svn divided by n. Okay, and the dk star is the sum of all the dks from year 1 to year n. Okay, so because every year the decrease dk is the same, so for k years it's gonna be k dks, so it's k times dk. Okay, and bvk, so the book value at the end of year k is gonna be the initial price, initial cost minus the cumulative dk through all the k years. Okay, so this is the formulas you're going to use, very easy to use. And this is an example. So to use the SL depreciation method, a laser surgical tool has a cost basis of 200,000. So cost basis of 200,000, that is B. And a 5-year depreciable life. 5-year depreciable life, that is N, right? The estimated SV of the laser is 20,000. Okay, so this is SV at the end of 5 years. Okay, determine the annual depreciation amounts. So this is DK, annual depreciation amounts, using the SL method. And also tabulate the annual depreciation amounts, the DK. So put the DK and the book value VK of the laser at the end of each year. So put those numbers in a table. Okay, because you're gonna have 5 years, and then you're gonna have like a table of 5 rows plus the first 0 year, and then you're gonna have like a 3 columns. One column is the end of year, second column is the DK, third column is the BVK. So basically you want to calculate the DK for every year and then the BVK for every year, and put these numbers in a table to show the answers. So first you need to calculate what is DK. So use this formula. Okay, so DK is B is 200,000, right? And SVN is 20,000 divided by N. N is 5. So the way you calculate this is you want to do the this part first. Okay, so 200,000 minus 20,000, it is 180,000. Okay, divided by 5, that is 36,000. So every year the depreciation is 36,000. Okay, and then so the book value, so, and because this is a SL depreciation, which means all the DKs are the same, so you know that D1 equals to D2 equals to D3 equals to D4 equals to D5 equals to what? Equals to 36,000. Okay, and BVK is B minus DK star. Okay, so for example, B for the at the end of the first year, the BV1 is B minus D1 star, which is 200,000 minus D1 star. D1 star is 1 times DK. So it's 200,000 minus 1 times 36,000, which is what? Which is 164,000. And you can use the same formula to calculate BV2. It is B minus D2 star. Okay, so it is 200,000 minus 2 times DK. Okay, this is the formula you're using. Okay, so it's 200,000 minus 2 times 36,000, which is 128,000. Okay, so just continue and then until you have BV5. Okay, and then you want to put all of this into this table. So you see, for year, number of years, you have at the beginning 0, and then you have year 1, year 2, year 3, year 4, year 5, okay? And then decay, because at the beginning you have no depreciation, it's not available, so it's a dash like that, which means it's not available. But after 1 year, at the end of the first year, okay, you're gonna have 36,000 depreciation, okay, because you use this laser for that first year. And then in the second year, in that year, your depreciation is also 36,000. The same to the third year, the fourth year, and the fifth year, okay? And the BVK, but if you want to also write the DK star, at the beginning it's 0 or it's not available, and in the first year, at the end of the first year, the DK star is 36,000. But at the end of the second year, the DK star is the cumulative depreciation. So it's the depreciation for the first year plus the depreciation in the second year. So it's gonna be 2 times 36,000. Okay, that's the sum of these two. Okay, and then for D3 star, so in the end of the third year, the cumulative depreciation is the sum of the 3 years. Okay, so it's gonna be 3 times 36,000. And then in the fourth year, the D4 star is gonna be 4 times 36,000. And at the end of the fifth year, it's gonna be 5 times 36,000. Okay, and BVK, you can use these formulas to calculate, and then you put them here. Okay, but you also want to know that BVK, for example, this number, this is the BV2, which is, we already calculated out, it's to 128,000, but it also equals to what? Equals to the previous year's BVK, which is BV1 minus the second year's depreciation, D2. So because the meaning of the book value of year 2 is based on the book value of year 1, you depreciate for another year, for year 2, right? So it's the book value of year 1 minus the depreciation in year 2. So it's BV1 minus D2. So you can use this number minus 36,000. It also equals to this number. Okay? This is just to let you understand the BVK in a better way. Okay. Another method we're going to learn is called declining balance, DB method. Okay, and this method determines, so the book value or the annual depreciation is determined by multiplying BV at the beginning of year by a fixed percentage. So BV is gonna time another ratio R, okay, and so for every year, your previous BV will time the fixed ratio R, and that this is gonna be your depreciation for that year K. So this is not a fixed depreciation anymore, and it's just a fixed percentage. So, and this percentage R is usually stated directly, so given in the problem statement. Okay, so in this way, the D1 won't be equal to D2, and it won't be equal to D3, and so on. Okay, so this is the major difference between the DB method and the SL method. Okay, so for DB method, your annual depreciation deduction is different, but for SL method, your annual depreciation deduction is always the same. Okay, that's the difference. And this DB method is preferred by businesses because they get more of the depreciation early compared to late. So at the early years, you get more depreciation deduction compared to using the SL method. So this is to tell you why. Look at this chart. So if you put the BVK, so this is the vertical axis is BVK, and the horizontal axis is the K, okay, year. So if you put the K and the BVK in an example on this chart, you will have these two lines to represent the BVK calculated by straight line method or declining balance method. So the blue line is the straight line method, giving you what is the BVK for each year, okay? And the red line is the declining method to tell you what is the BVK for each year. So assume you have to know that these two lines are based on the same example, so which means the same set of numbers for BV, for B, and for number of years. But if you look at the early years, maybe year 2, okay, you can see that the book value calculated by declining method is lower than the book value calculated by the SL method. Okay, so BVK calculated by the DB is smaller than BVK calculated by SL at the same time point. Okay, which means you saved a lot at the beginning of the time, which means you can reduce more tax by using DB method. That's why the businesses, they love DB method, okay? And another thing about this chart is that you can see at the end of the SL method, this line will touch the vertical axis, which means the book value at this moment will be 0. Okay, but for the declining method, you will see that this red line, it will getting closer and closer to this horizontal axis, but it never touches it, which means the book value will just get closer to 0, but never equals to 0. Okay, so this statement is true that in SD method, it's SL method, okay, the BV could reach 0, but in DB method, the BV never reaches 0. So the two methods, they both have good and bad things, okay? For SL method, maybe at the beginning of the timeline, you won't have that much depreciation deduction as the DB method, but at the end, you will reach the 0 value, okay? Which means at the end, at some time point later, you won't have any book value to depreciate. So you recovered all the value of that, the initial cost. and that's also what you like. But the DB method will let you have more depreciation deduction at the early years, but it never reaches zero value at the end. Okay, so this is also good, especially for those business which are not, stable. Like you don't know if it will last or be successful for a long time. So you want to have more benefit as early as possible, which means you want a higher depreciation deduction as early as possible. So most of the businesses, they like the DB method to calculate depreciation deduction. So let's talk about the formula of DB method. We know there is something new. It's called the depreciation rate. It is always given in the problem statement. Okay, so that rate determines what is your annual depreciation deduction. So every year you use your new BV times the R. Okay, so you use the previous year's book value times the R. That's your depreciation deduction for that year. So all the other variables, they are the same concept. And so formula wise, D1 equals to B times R, okay? And dk equals to B times 1 minus R to the power of k minus 1 times R. Okay? And dk star is B times 1 minus the whole 1 minus R to the power of k. Okay, this is just a complicated formula, and you need to know the order of operation. Okay, you always want to start with the parenthesis, calculate that, and do the power, and then you do the bracket. Okay, so parenthesis first and the bracket second, and then the multiplication outside. Okay, and BVK is B times 1 minus R in the parentheses to the power of k. So you want to do the things in the parentheses and then do the power and then times B. Okay. And because you can tell in this formula the k is included. So if k changes, the dk changes, which means we should prove again that the D1 is not equal to D2, okay? And then so on. So all the dk's, they're different. So let's take a look at this example. A new electric saw for cutting small pieces of lumber in a furniture manufacturing plant has a cost basis of 4,000. So this is B. And a 10-year depreciable life. This is N. The estimated SV of the saw is 0. So SV 10 is 0. Use the DB method to calculate the annual depreciation amounts when. So we have two questions, two scenarios. When R, the depreciation rate is 2 divided by N. N is 10, so 2 divided by N is 0.2. And another scenario is when R is 1.5 divided by N. So 1.5 divided by N is 0.15. So under these two scenarios, what is the dk? And also they ask you to put these numbers, the dk star, and bvk in the table. Okay, so let's use the formula to calculate dk because dk is related to k, so it's a function related to k. So we need to use k equals to 1, k equals to 2, k equals to 3, and so on until k equals to 10 to calculate the dk for each year. Okay, so D1 is, in the formula, it is B times R B is 4,000. R is, for the first scenario, 0.2. So this is 800. Okay, so you put that here. And D2 is B. So I'll just substitute the letters with the numbers. It's 4,000 times 1 minus 0.2 to the power of 2 minus 1. And a time another 0.2. Okay, so this value is gonna be 640. And this is what you put here. And the D3 is gonna be 4,000 times 1 minus 0.2 to the power of 3 minus 1 times 0.2. And this result is gonna be 512. So you wanna put it here. Okay, and so on until you calculate all the 10 years decay. Okay, and then the decay star, let's do one example. So D1 star is 4,000 times 1 minus 1 minus 0.2 to the power of 1. Okay, so it's 4,000 times what? 1 minus 0.2 is 0.8. Okay, to the power of 1. So this is 4,000 times 0.2, which is 800. So you put it here. Okay, and then let's do another example for D2 star. It is 4,000 times 1 minus 0.2. K is 2. This is 4,000 times, you do the parentheses first, okay? So 0.8 to the power of 2. And then you do the power. 0.8 to the power of 2 is 0.64. And then you do the parentheses. It is 0.36. And this will give you 1440. And you put it here. So basically you just repeat using these formulas, and then you calculate the D1, D2 until D10, and also D1 star, D2 star until D10 star, and put it in the table. And also you use the BVK, this formula, to calculate the BVK. Okay, and then you're gonna just have this table. So the DB method is very straightforward. You just use the formulas to calculate the depreciation deduction for every year.